To last two lecture, we are start with the basics about mechanics and types of mechanics were static and dynamic, kinematics and kinetics. Then machinery, mechanism and machine structure, difference between machine and structure. After that, we discuss about kinematic link, pair and chain in detail. Types of kinematic link, types of kinematic pair and chain, where links are divided in rigid link, flexible link, fluid link, and we also discuss about the types of rigid link, then what the meaning of rigid, flexible, and fluid link, and where it may be used, right? Binary link is there, ternary link is there, and quaternary link. These three are the types of rigid link. Then discuss about the pairs. Different kinds of pairs are there, and what are the basic example of that all pairs that we discussed in first lecture. After that, in second lecture, we discuss about the kinematic chain, at where we know there are two conditions which fulfill the requirement of kinematic chain, that is L is equal to P minus 4 and J is equal to 3 by 2 L minus 2, right? Now, so based on that, we are divide the motions in completely constrained, uncompletely constrained, and successfully constrained also. Based on that, if they fulfill the requirement, then it called as a lock chain. If not fulfilled, then it called as a constraint chain. And if less than the remaining value, then it called as a unconstrained chain. Okay, so after that, we discuss about the joints, degree of freedom, which is very important point. We also discuss about the movability and mobility, difference between movability and mobility also. Then we define the equation of KUTZBACH criteria, where if H is equal to 0, then what is the equation for KUTZBACH criteria N, and if H is present, then what is the equation for degree of freedom N? The equation is 3 of L minus 1 minus 2J minus H, right? And applications regarding KUTZBACH criteria, already I define minimum 2 or 3 point. So remaining you were trying to finish with your way. So how many degree of freedom you are getting in D, E, and F, that you have to just mention in the comment box. So if your answer is right, then I will just check your answer. After that, we discussed initially that what the meaning of spatial mechanism and how it may be defined. And after that, based on that, Grubler's criteria we are discuss. Now, after end of the Grubler's criteria, let's start regarding the inversion of mechanism. As we know very well, when we talk about mechanism, on that time, there is one condition that any one link should be fixed, right? It is called as a mechanism. Now talk about the inversion, the method of obtaining different mechanism by fixing different link. Remember this point. Suppose I have a forward chain mechanism, okay, where there are 4 links which are attached with each other, okay, and from that link, initially any one link is fixed. Okay, after that, I just change the fixing link. पहले एक link fix है, उसके बाद दूसरी link fix है. Means the fixing different kind of links in a kinematic chain that we discuss in the laboratory session also. After the end of this topic, inversion of mechanism, whenever it may be completed, we are directly start the inversion of mechanism, actually how it implement. So on that time, your funda may be clear. So you remember that every time different links are fixed, and whichever the mechanism we are generated, that is called as a inversion of mechanism. Mostly, if we talk about the inversion, then it may divide in forward chain mechanism, single slider crank chain, and double slider crank. Okay, so types of kinematic chain is divided in this three way. 4-bar chain means there are only 4 links. In 4 links, any one link is fixed. Slider crank chain, mostly it may be useful in automobile parts. Slider crank chain and double slider crank chain, where 2 sliders are there and it may be revolve or rotate in its own position. So it is called as a double crank chain. Okay, in this 3-way kinematic chain is divided. Now talk about the 4-bar chain. So this is the look of 4-bar chain. You can just see it here. Right now in figure A, one link is fixed. Okay, in figure A, one link is fixed. That's why it is called as a 4-bar chain mechanism. This is one link, this is second, third, and this is fourth link. Now I just change the fixing link. पहले ये link fixed. Now I just change the fixing link. Right now this link is, it may be fixed. It means that the different links are fixed one by one. So it is called as a one kind of mechanism. Okay, it is called as a one kind of inversion of mechanism. It is called as a 4-bar chain inversion. Inversion of 4-bar chain are divided in beam engine, coupled locomotive wheels, Watt's indicator mechanism, pantograph, and Ackermann's mechanism. You remember that in 4-bar mechanism, it may cover beam engine, coupled locomotive wheel, Watt's indicator mechanism, pantograph, and Ackermann's mechanism. Okay, these all are considered in the inversion of 4-bar chain. We have to discuss totally 3 types of inversion. That is 4-bar chain, slider crank chain, and double slider crank chain. Right now we start with the 4-bar, then slider crank, and then double slider crank. Now in 4-bar chain, as I discussed earlier, beam engine is the first inversion. We are focused right now on the 4-bar chain mechanism inversion only. Okay, so in first inversion, it may be known as a beam engine. Second inversion, it is called as a coupling rod of locomotive. And third inversion is known as a Watt's indicator mechanism, pantograph, and Ackermann's steering gear mechanism. So these kind of mechanism are actually practically available. Okay, at somewhere, at any machine, it is fixed and it may be working with these kind of inversion. Okay, so it may indirectly useful to you in the engine mechanism mostly. We have discussed one by one in detail. Before that, one law is important, that is Grashopp's law that we discuss, and after that I'm going to give some depth introduction about all the three inversion of 4-bar chain mechanism. You remember each and everything regarding talking regarding the inversion. If we talk about the inversion, then inversion is what? Kind of different kind of links are fixed one by one, then it called as inversion. It divide in 3 parts: 4-bar chain inversion, slider crank chain inversion, and double slider crank chain inversion. Okay, right now we start with the 4-bar chain inversion. In 4-bar chain inversion, it may divide in beam engine, coupled locomotive engine, Watt's indicator mechanism, pantograph, and Ackermann. Now if we are properly define this all the inversion of 4-bar chain, then it divide in this 3 way: first inversion, second inversion, and third inversion. Okay, so beam engine is the basic of 4-bar chain inversion. Then intermediate stage is we are considered as a second inversion, and the latest inversion right now it may be work, it is called as a third inversion. Mostly If we talk about Ackerman steering gear mechanism, it may use in the four-wheeler car, pantograph, which are used to zoom in or zoom out of the uh, diagram, and Watt's indicator mechanism are used in the pendulum. Now talk about the Grashopp's law. In four-bar chain is the simplest kinematic chain, which consists of 4 links, right? Why it called as a four-bar chain? Because it consists of 4 links and 4 number of pairs. Okay, 4 links and 4 number of pairs. As per the Grashopp's law, one of the link must have a complete revolution in four-bar chain. You remember that as per Grashopp's law, one of the link have complete revolution in four-bar chain. Four-bar chain में any one link should have complete revolution. Okay, to make it useful mechanism. If you want to make for useful for somewhere, then any one link should have complete revolution motion as per Grashopp's law. If now how we have to implement? For implementing that law, we have to just identify this equation that the sum of length of shortest link and largest link should not be greater than the sum of the remaining 2 links. Okay, there are 4 links. So from that 4 links, any two, not any two, but the smallest link, shortest link, and longest link, वो दोनों का summation करना है हमें, and that summation should not be should not be greater than remaining 2 links. It means that remaining 2 links are higher than the summation of shortest and longest link. Then and then it call as a, or it follow the law of Grashopp's law. There are 3 cases totally that we are discussing right now, and then we are implement in the our first practical that we start in the next session. Case 1 where where we talk about this shortest and longest link. The summation of shortest and longest link is less than remaining 2 link. If it less than, then what happen? If four-bar chain satisfy the above condition, then it called as a Grashoppian four-bar linkage. Okay, then it is considered as a Grashoppian four-bar mechanism. Now, the link which is having complete revolution, as I discussed earlier, that if any one link is complete revolution, that is one condition of Grashopp's law. So, if any one link have complete revolution, then it called as a crank. You remember that? If any one link have complete revolution, then it called as a crank. The link which oscillate is known as a rocker, and the link which connect with crank and rocker, is called as a coupler. Okay, so there are 3 phenomena that you have to remember. Which completely revolve, it called as a crank. Which oscillate in its own position, it called as a rocker. And to join crank and rocker, it is called as a coupler. So crank, rocker, and coupler is there. Now for the Grashopp's law, as per the condition 1, case 1, if it fulfill, then what happens? Shortest link is known as a double crank mechanism. Adjust to shortest link, it called as a crank and rocker mechanism. And opposite to shortest link, you just remember A, B, C, and D that I show you one by one all these 4 figure. In the first figure, where shortest link is this, which is fixed, that's why this is the mechanism. It is known as a double crank mechanism. Okay, that we discussed in detail in the first practical that why it may be double crank and what are the condition. Definitely there are once again we are use the same rule, same law, Grashopp's law. So on that time I discuss in detail regarding why there are two double crank. The name is why that there is a name is double crank. There is some condition that we discuss after end of this lecture. It means in the second lecture. The second figure and third figure are based on the nearer to the shortest link. Means ये shortest link है उसके नजदीक की ये link. Okay, this link and this link. Okay, this is the shortest, so these and these two links. So these are known as a crank and rocker mechanism. And remaining last one means opposite to the shortest link. Opposite to the shortest link. You just see in the table, so it may be very clear in your mind. Opposite to the shortest link is known as a double rocker mechanism. Okay, we are applying some equation also in the practical. So on that time, you probably understand that about Grashopp's law in detail. Same way, if the condition where smallest and longest link, the summation of shortest and longest link is higher than remaining two link, then it definitely called as a non-Grashoppian Forbar linkage. Okay, so on that time, which no link make a complete revolution. So definitely we are not get any kind of double crank or crank mechanism. On that time we are get only rocker mechanism. Okay, so on that time when this condition apply, when the shortest link and longest link, the summation of shortest and longest link is higher than remaining two link, on that time definitely the complete revolution is not possible. So there is no double crank mechanism, only there is rocker mechanism. Okay, so either it may be shortest link or it may be adjacent shortest or opposite of the to the shortest link. Okay, so these are the some mechanism that you may consider for double rocker mechanism, where the condition is S plus L is greater than A plus B. Now suppose we are consider about, as we know, the equation, the condition is less than or equal to. We are talking about the less than, we are talking about greater than, now talking about the equal to. It means that in the equal to condition, when two opposite links are in same length, then definitely any one of the shortest link and definitely any one is the longest link. Okay, if any one is the shortest link is there, then it called as a double crank, and any one is longest link, then some another is also shortest link, so it is also known as a double crank. So you remember that on that time double crank mechanism is for this. But if any two adjacent link are equal, if any two, there are two cases. In first case, two opposite links are in the same length. If two opposite length are same, I just give one example. Suppose these are the two links. If both are same length, then we are get only double crank mechanism. Okay. If these two are in the same length, either these or these or these or this, then it is called as a double crank mechanism. But if adjacent link are equal, means we are not talking about these two, but we are talking about these two. Then we
Sir, your voice is not clear.
Grashopp's law is, wait. Okay. Grashopp's law is explained in this way properly, that if the summation of shortest link and longest link is less than or equal to a plus b, it is the condition for Grashopp's law. If less than, if shortest plus longest is less than a plus b, then definitely there is a three condition, either double crank, crank and rocker, and double rocker. Okay, but if greater than, then definitely we are getting only double rocker mechanism. But if we talk about the third condition where both length are equal, when we talk about the same length in opposite side, then only we are getting the double crank. But when we talk about the adjacent link which may be equal, then either double crank and rocker mechanism is created. We are discussing each and every condition in detail with the equation in the practical number 1. Now start with one by one types of inversion. As I discussed earlier, the first inversion that already we just show you in this slide, previous slide, that first inversion is based on beam engine. You can just see in the figure, this is you can see here, this is the first link, it is considered as a first link, this is considered as a second link, this is third link, and this is the fourth link. Here we are get some output. Okay, here we are get some output. So the crank, this the crank rotates.
Sir, you are
Sir, your
muted.
voice is not audible.
Okay, this is the first inversion of beam engine, where this is the first link, second link, third link, and this is the fourth link. And here we are get the output. Okay. If we talk about the second link, that may be considered as a crank, which rotates about the fixed center, which may rotate, as you can see in here, the direction is given to you. So, and this O is the center. So its own center, it may rotate. Due to its rotation, rocker, it may oscillate. What happened? The rocker, it may oscillate. It may oscillate. You just see the arrow which I show with the mouse. So a rocker which may oscillate about fixed center. This is the center. From this center, it may oscillate with the help of this fixed rotation of the crank. And due to that, we are getting the reciprocating motion inside the cylinder. Okay. Due to that, we are getting the reciprocating motion inside the cylinder. So this is the beam engine, which may most probably use in the rotary motion in reciprocating motion. Mostly it may use in the rotary motion into converting rotary motion into reciprocating motion. Okay, this is the rotary motion which may connected with the help of this link number 3, and which may join or it may oscillate to link number 4, and we are get the output in the reciprocating motion. So this is the one mechanism which is the first inversion, or it is known as a beam engine. Sometime it may ask in your exam directly that explain beam engine. So you have to draw the figure and then you have to explain in short and sweet. Okay. After drawing the figure, you have to explain that what kind of motion is converted in which way. So it is enough to, but your figure is very important. Next one is second inversion, or it is called as a coupling rod of locomotive. If you can see in the diagram, then there are two links, link AD and link BC, which are, this is link 2 and this is link 4. Okay, link 2 and link 4, while the remaining two, link 1 and link 3, are of the same length. Okay. From the figure, if we can say that
Sir, your voice is breaking.
Sorry, your voice is breaking.
connected with the, okay, 1 minute. From the figure,
Sir, you are muted.
yes. Okay. Now from the figure, we are consider that the link AD and link BC are connected with link 1. Okay, and one another thing is there, AD and BC are considered as a crank because both are revolved completely. So AB is fixed link, while this CD is known as a coupler. AB is a fixed link, while CD is known as a coupler, and the mechanism is transmit the rotary motion from one wheel to the other wheel. Okay, it may transmit, definitely there is rotary motion because it may behave like a crank, and it may convert in also rotary motion. Okay, in beam engine, rotary motion is converted in the reciprocating motion, while in coupling rod of a locomotive, rotary motion is converted in the rotary motion. Okay, so at that kind of mechanism where if we require the rotary motion in the rotary motion, on that time coupling rod of locomotive kind of inversion is used. Third one, that is Watt's indicator mechanism, or we are considered as a double rocker mechanism. Okay, Watt's indicator mechanism, or we are considered as a Watt's indicator mechanism. The figure is somewhat complicated, so the dotted portion is considered as a after movement. So you just see the diagram, which may give you the A, D, B means AB, AB, C, D, E, F. Okay, and this is the uh, condition after applying the load, as shown in figure. Here, see, wherever this kind of symbol is given to you, it shows that it is a fix. Means we are considered that from the figure, this link means link 1 is a fix at A. Okay, link 1 is fixed at A. Then DE and EF. This is fixed at one end. DE and EF is also generate one link. This whole is one link, but there is no relative motion between them. Now, third one link is ADB. Third link is the ADB, while link 3 is BFC. Okay, the whole links are converted in this way. The first link, which is fixed, the second link, this is the second link where there is no relative motion. The another link is ADB, and the fourth one link we are considered here, it is BFC. Where this link BFC is considered as a lever, or which act as a lever, depending upon the gas or steam pressure acting on the plunger, depending on the gas or steam pressure acting upon the plunger. This is the plunger. Okay, the arrow shows the direction of either gas or the pressure of the steam. Due to that, what happened? This link, it may move. Okay, what happened due to this? It may move. Okay, so tracing point, definitely this may move. Due to that, what happened? This C may reach up to C dash, E reach up to E dash, and due to this point, we are getting B at point B dash. On that time, the whole mechanism are behave like this way: A, B dash, F dash, C dash, with A, where intermediate point is E dash. Okay, tracing point at the end of the link trace out approximately, you can just see it here, which may approximately straight line motion. Okay, initial position of the next position, initial position and next position. Initial position means E, and next position means dash of the mechanism, which shown initial position may not in the line position, but after applying the pressure, after applying the load on the plunger, the whole mechanism are behave like approximate straight line. Okay, which shown with the dotted line AC dash. Why the name is approximate? Because that depends on the pressure which you create, which you generate. Okay, so these are the third inversion of four-bar chain mechanism. So right now we are discussing about the mechanism, four-bar chain mechanism, where first inversion of four-bar chain mechanism, beam engine. Second inversion of four-bar mechanism is coupling rod and locomotive. Third inversion of four-bar chain mechanism is known as a Watt's indicator mechanism or double rocker mechanism. Now, next one is single slider crank chain. Already you know about this mechanism in BME also, how it works, which may helpful to you in IC engine particularly, where this is the first link which may fix, the second link it may crank, the third link it is known as a connecting rod, and the fourth link it is known as a piston, which may reciprocate. With the help of the rotary motion, we are converting the reciprocating motion in single sided crank chain. Now, as we discussed previously regarding four-bar chain mechanism, same way we are discuss about the inversion of slider crank mechanism. The first one is the reciprocating engine that we discussed. Reciprocating engine, reciprocating compressor, Whitworth quick return motion mechanism, rotary engine, crank and slotted lever mechanism, oscillating cylinder engine, ball engine, and pump engine. So these are the some basic inversion of slider crank chain. We are trying to cover all the slider crank chain inversion. Start with one by one. That is, first one is reciprocating engine. As we had discussed, the reciprocating engine, it is a one kind of first inversion of slider crank chain, where definitely link 1 is fixed, link 2 is known as a crank, link 3 is known as a connecting rod, and link 4 is slider or piston. Okay, so here we are converting the reciprocating motion in rotary motion. Before that, it is compulsory to understand that it may divide in 4 types or 4 inversion. First inversion, first is the primary inversion, second and third is the intermediate inversion, and fourth one is the latest inversion of second, or we are considered that single slider crank chain inversion. Okay, so now we are discuss one by one all the first, second, third, and fourth inversion. As you know very well, in forward chain inversion, there are 3 kind of inversion. While talk about the single slider crank chain, there are 4 kind of inversion. So sometime only directly ask in your exam that define inversions of single slider crank chain. Okay, many time it may ask in your exam that explain or define inversions of single slider crank chain. Then you have to draw this figure. After that, you define in this way, that this way, and then you elaborate each and every part in proper way. That depends on the marks. First inversion, as I discussed earlier, so this is known as a reciprocating engine. Same thing apply for reciprocating compressor, where with the help of this connecting rod, it may the piston may reciprocate, and with the help of this piston, we are generate the enough pressure. That depends on our requirement, right? So this is the first link, which may be considered as a fixed, or we are considered as a fixed link cylinder. Then this is the second link. It is called as a driving crank. Third link is called as a connecting rod, and fourth link, it is known as a slider or piston. Okay, very important. That is second inversion, or we are considered as a Whitworth quick return mechanism, which also we discuss in the second practical. This mechanism mostly used in shaper mechanism or shaper machine. You just see here from the diagram, we are considered that this link is fixed, means link 2 is fixed. Okay, this link is fixed means link 2 is fixed. Now you can see here from this point to this means CA, right now. Link 3, or we are considered that link 3. Link 3 rotates at uniform angular speed. Link 3 is rotate with its uniform angular speed. Okay, link 4 is connected you can just see here, this is link 4 which is connected to link 3 at point A. This point is known as a crank pin. Okay, this point is known as a crank pin and slides along the and slides. This may rotate in this way. Okay, and slider 4 is this, and slaughter is link 1 this. But when this point is revolve in its own axis, on that time the slider slides along the slotted bar, along the slotted bar, or along the link 1. Slotted bar will oscillate, means oscillation means if you remember that the old clock where pendulum is there. Okay, so it is the motion is known as a oscillation. Okay, so that kind of oscillation motion we are generate from the figure. A slotted arm will oscillate with respect to pivot point. You can just see here the slotted arm which may oscillate with respect to this pivot point. Okay, connecting rod carries the ram. Connecting rod, you just see the diagram which may very easy for you. Connecting rod carries the ram with cutting tool which is constrained to move along the straight path. Okay, it may move in the straight path with the help of this all the hidden mechanism. During the cutting stroke, you remember that in your mind that how shaper machine is work. There are two kind of stroke: cutting stroke and return stroke. In cutting stroke means you can just see here cutting stroke and return stroke. In cutting stroke, it may cut the material, while the return stroke is ideal, means there is no any uh, job may cut in the return stroke, means return stroke definitely ideal. So it may cut the job in cutting stroke only, while it may revolve in its own axis and link 4 may slide in its own axis. So during the cutting stroke, driving crank move. During the cutting stroke, driving crank move from O CA1 to CA2. Okay, you remember that it is the maximum point and this is the minimum point. Okay, where focus with the C point. So CA1 and CO2, CA2. We are also draw this diagram in the second practical. And the cutting tool moves from, and cutting tool is moves from R1 to R2. Okay, the whole, I repeat, the cutting stroke from CA1 to CA2. On that time, suppose initially the position of the stroke is at CA1. On that time the tool is at R2 condition, while when the condition of CA2, on that time the tool is at R2 condition. Okay, so during the backward stroke, or we are considered that return stroke or non-cutting stroke, driving crank moves from CA2 to CA1 and make the angle beta. We are assumed that the make the angle beta. Okay, so one can observe that angle alpha. You can just see here, this is the angle alpha is larger than angle beta. It means that what it means that time taken by the tool is less during backward stroke. This is the prime condition for shaper machine, because in backward stroke, in return stroke, which may be ideal, which may non-cutting stroke, that's why it definitely the time should be less to return return come in its own position. So definitely this beta is always less than the alpha. So the ratio between the time taken during the cutting stroke and backward stroke is equal to alpha divided by beta, or we can say that time of cutting stroke means in the cutting stroke means this is the alpha, it is called as a cutting stroke, divided by return stroke means beta. Alpha divided by beta, or we are considered that alpha divided by beta means 360 minus alpha, right? 360 minus alpha. Okay, so we are considering this way also. Okay, 1 minute. Okay, so as per the planner machine, or as per the shaper machine, or as per the slaughter machine, the condition is that every time this beta should be smaller, or we are considered that the ratio between time of cutting stroke alpha divided by time of non-cutting stroke beta is equal to alpha divided by 360 minus alpha. Okay, beta means what? 360 minus alpha. Okay, so this kind of mechanism are useful in shaper machine and slaughter machine to cut the metal, cut the material in cutting stroke. Okay, it is called as a Whitworth quick return motion mechanism, or we are considered that second inversion of crank static crank mechanism, single static crank mechanism. Now, next one is the rotary engine. Now, next one is the rotary engine. You can just see the figure. From the figure, you are give the idea that there are 1, 2, 3, 4, 5, and 6 and 7. There are almost 7 cylinders. So it may use where 7 cylinder piston are used. On that time, we have preferred to use the rotary engine mechanism. Okay, so you can just see here where this link is fixed, link to, while these all are considered as a cylinder. Okay, so these all are the cylinder. Then link 4, which is known as a connecting rod. Link 4 is a connecting rod, while link 3 is a piston. Okay. Link 2, which is fixed. Link 1 is a cylinder. Link 3 is known as a piston, while link 4 is known as a connecting rod. It consists of 7 to 9 cylinders. Wherever 7 to 9 cylinders are there, on that time we are preferred to use rotary engine mechanism. Okay, so on that time we are preferred to use rotary engine. Now, next one, that is third inversion, or it is known as a oscillating cylinder engine, or it is known as a oscillating cylinder engine. As you can just see the diagram, link 1 is there. Okay, link 1 is there. Link 3 is there. Here, it may be fixed. Right now, it may be fixed. So it is called as a link 2. Here, the fixing point is there. And link 3, it may oscillate. And this fourth one, it may be reciprocated. Okay, so as shown in figure, this link 3 is the cylinder. and link 4, which is reciprocate in its own axis, while on that time this link 1 is rotates. Okay, here we are getting the rotary motion in the oscillating motion, rotary motion in the reciprocating motion. Mostly this kind of mechanism we are getting in the cylinder oscillates, where fulcrum is there and which may start to oscillate in any one position. So on that time we're trying to use this kind of mechanism. So it is called as the oscillating cylinder engine. You are trying in your way that this kind of mechanism are where are which place it may use. So try to find the one or two example of each and every mechanism. Either it may be forward mechanism or it may be single Stadthaken mechanism. This is the last of single Stadthaken mechanism, that is crank and slotted lever mechanism. Mostly it may also near to same like Whitworth mechanism. In Whitworth mechanism, this may fix and this link 4 may be slide, while link 1 may be slotted in its own axis. On that time, the connecting rod may be reciprocate the tool. Either we are get the motion of cutting stroke or non-cutting stroke. Here, it may use mostly in both the machine like shaper and slaughter, but this mechanism, the crank and slotted lever mechanism, are mostly used in slotted machine only, where to prepare or to make the slot. Okay, you can just see the diagram. From the diagram, wherever you draw the diagram, you have to identify that which link is fixed and what is the angle. Either it may be a Whitworth quick return motion mechanism or it may be crank and slotted lever mechanism. You understand that when we find the angle in practical laboratory, so on that time we are draw these all the figures with the proper dimension as shown in figure. The link 2, which is crank, the link 2 which is crank, which may rotates with uniform angular speed about center C. Right now, link 1, you can see here the link 1, it is known as a slider. Link 1, it is called as a slider. As we seen in the previous Whitworth mechanism, is connected at the end of the driving crank, is connected at the end of the driving crank, and it slides along the length of the slotted arm, and it may slide with the length of the slotted arm. Slotted arm, the link 4, yeah, this is the link 4. This is known as a slotted arm. This is fixed link, which is known as a link 3. This is link 2, which is revolve, and link 1, which may slide. Okay, the phenomena are same, but the situation are somewhat different. Okay, slotted arm is having a accelerating motion with respect to point A. Okay, accelerating motion with respect to point A. AO is fixed. Here AC. AC is a fixed, which is known as a link 3. So what happened here? Cutting tool is connected. Cutting tool is connected to the slotted bun by the connecting rod. slotted bund by the connecting rod, and it is constrained to move in a straight line. Okay, and it move in the straight line. During the cutting stroke, our objective is to tool may reciprocate in its own straight line motion. For that, this whole mechanism are generated. Okay, and cutting tool moves from R to R2. Cutting tool moves from, this is the tool which may moves from here to here, and during the backward stroke, it may create the angle like AB1 and AB2. Okay, AB1 and AB2. So on that time, we are definitely generate the cutting stroke and non-cutting stroke. So this is known as a beta, or it is called as a cutting stroke, and this is called as a alpha, or we are considered as a 360 minus beta. This mechanism are mostly used in shaping machine and slotting machine. Okay, so these are the some basic about inversion of slider single slider mechanism. Yet one is remaining that we discuss later, and then we are jump on the practical. I just request to all that please trying to find this all kind of mechanism in example point of view, so it may very beneficial to you.